Hello, everyone. Welcome to the live stream today. Today, we're going to talk about optimizing geospatial ETL at Comcast. So I'm excited to be joined by David from Comcast. And I'm also, my name is Jia. I'm the creator of Apache Sedona. And David and his team has been leveraging Apache Sedona for geospatial analytics at scale at Comcast. And today, we are going to dive into their journey and the challenges they have overcome and the impact Sedona has had in their team. And David, thanks for joining us today. And let's start it by knowing a little bit more about you.
Yes, thank you so much. And I'm so glad to be here and share our journey with Apache Sedona. So background me, I joined Comcast around 4 years ago. I was primarily a data analysis, a data scientist, and within the last few years, kind of transitioned to a lot of data engineering work. In the past, I worked a lot with network expansion, so creating new fiber connections for different areas within the Comcast footprint. And now my current team is working on Xfinity Mobile.
Cool, that's great to learn. Tell us a little bit more about your Sedona journey. And for example, how did you first come across Apache Sedona?
Yeah, definitely. So, originally the first team I was on was that team that dealt with network expansion and like customer satisfaction. And we were just working on our local laptops, local machine, utilizing Jupyter Notebook and GeoPandas for our ETL. Our scope of work was a little bit more limited, and the data sets weren't quite as large. So we weren't quite there yet for the need of big data. And we went from GeoPandas to ArcGIS Desktop for doing a lot of our analytics. And we're producing really great results. And so we kept getting more and more work, more data sets, more requests. And so there was this need to transition from these ad hoc requests to these requests that could be scaled for more areas, more locations. And that's really when our team started looking into Spark and other compute infrastructure that allows us to perform things at scale. And I heard about Apache Sedona just looking through what tool is available for doing geospatial joins and analytics, but within a Spark ecosystem or in a distributed ecosystem. And so it's a Google search, and yeah, I haven't left it since.
Oh, yeah, sounds like spatial drawing is one of the key problems you are using Sedona to work on. So what are some of the other challenges you have been trying to solve using Sedona?
Oh, could you say that one more time?
Yeah, what are the other key challenges you are you're solving using Apache Sedona?
Yeah, exactly. Yeah, definitely. So, Apache Sedona, because it's Spark native and that ability to scale up and down, it the key challenge a lot of the times is is the data volume such that you can perform your joins and turn around the analysis within the time frame that's required by the business, right? People want to have accurate, fast analytics so that they can iterate quickly or meet certain deadlines. So, in the past, one thing we were working with deadlines given by the government for allocating or for applying for government grants, and we get some crazy timelines like within a week, and you might have an entire state worth of information, many millions of data points or millions of polygons that have to be joined against other, millions of polygons, and they're going to want you to turn around within a few days. And so, with GeoPandas or some of the other previous tools I'm talking about, it could take up to a full day to run those pipelines. But with Apache Sedona and the compute infrastructure, the ability to scale, we cut down that time. And so that was really the key challenge, is the volume of data and then the repeatability. Because let's say a requirement changes from whatever customer that you're supporting. Well, can I rerun that ETL within a few hours, within a minute? That was the other key challenge, is how fast can we iterate, because things are constantly changing, right?
Yeah, exactly. I think one of the very important things that can help with folks in the community is, like you said, reduce iteration time. Sometimes, although in some cases people are saying that, okay, so I for those kind of analytics queries, so uh, uh, it is okay to run it like a bit longer, say like half hour, but Sedona is able to reduce that time to even minutes level that greatly reduce the iteration time, save lots of time from for the team and for the developer as well. Cool. Another question, right? So
Mhm.
Sedona is an open source software, and many people have been loving open source software, right? Did you see Sedona kind of help you guys to reduce situations like vendor lock-in?
Yeah, definitely. So I mean, there's lots of great things about open source. One thing, getting approvals from uh, you know from any company, but especially larger companies that may have long processes to onboard vendors. As soon as you have open source, you get approvals right away, and so that one speed to get started is fantastic. Then to your point, like vendor lock-in, if you're using something like ArcGIS Desktop, which is still heavily utilized within Comcast, getting the licenses, it may just be for one team member, but if because it's open source, you can have many different team members all utilizing the same tool, and they don't have to worry about the licensing. Another thing that I love, if you're using AWS or one of the other large cloud providers, AWS, GCP, Azure, because Sedona is just Spark, you can lift and shift your scripts that use the native Spark implementations to any of the different cloud providers. So you're not stuck in one location with a function that's specific to uh, that Redshift cluster, or a different one like Trino or Starburst. You, it's just like, here's my script, go for it. That's for our team internally, but also for other teams. If our team's an AWS shop, Comcast is so big, we have access to a lot of the different cloud providers. So, if our team's an AWS shop and another team's only using Azure, they can also run their Spark ETL with the Sedona. And so there's not this disconnect. So again, it goes back to that faster iteration, more like easier collaboration as well. And so that's been really helpful. I guess one final point I'll make too is, if we don't have, sometimes you'll run into teams that may not have a very large cloud budget, and so maybe the company assumes that on-prem is free for the teams that utilize the on-prem resources, and so that's a common thing that will come up as well. So let's say my cloud budget today might not be my cloud budget tomorrow. Can we move to an on-prem cloud servers? And Sedona can, right? Because it goes back to the Spark. And so there's many teams that uh, you know have it that way within Comcast, I'll say.
Cool. Oh yes, thanks for sharing that. Glad to know. Uh, cool. I know in the call today, there are lots of new Sedona user probably. And so for new users, right? So what functions would you suggest and recommend so they can start with?
Definitely. My favorite function is probably one of the most simple, is st underscore intersects. So basically is your point geometry, your line geometry, intersecting, or polygon geometry intersecting with another. So it's incredibly powerful because you get, are these, I'm from the Xfinity mobile perspective, you know, is your user within a coverage area? So if your coverage area is this custom polygon, are they within it? Can they expect coverage from you? Right. That's a very common thing when you're doing, customer experience analysis. So it's a function I use all the time. It's kind of the workhorse, I would say. So I highly recommend that one. And then other more complicated functions, I really love ST union aggregate. So if you want to have multiple geometries, but you need it in a single object, so that you can um, either for data visualization purposes, or so you can create primary keys within your different SQL databases, I think it's also very powerful. But yeah,
Oh,
those two are two of my favorites for sure. Do you
oh
have a
yeah, yeah.
particular function that you loved implementing within Apache Sedona, or uh, what would be your recommendation? I'm very curious.
Yeah, so I think of course the ICT intersect is the probably the most important one. Like there are a bunch of functions that are centered around the ICT intersect, right? So ICT contains
Yeah.
and ICT within, they're also relevant. Another new functions I also love is the ICD within. So this is a function we probably I think introduced probably a year and a half ago. So the good
Hmm.
thing about STD within is so it allows you to supply a distance in addition to the within function. So meaning that you can kind of perform sort of distance query or distance join uh, using the same predicate. So this is something that is really powerful, and if users want to try, I think that's a really good function. Uh, what else? I think mm, another really important feature, I think that many people have been looking for is the k-nearest neighbor join. And David, you also
Yep.
mentioned this before. This is a question you asked us before, like when we're
Yeah.
gonna have this function, right? Like we finally released the k-nearest neighbor join, I think last year, right? So basically, it allows you to say you have a bunch of drivers, right? You have
Hmm.
hundreds of thousands of drivers. You want to find the nearest 5 restaurant per driver, right? So that's a k-nearest neighbor join. And the last year we released a distributed algorithm that can handle the k-nearest neighbor join in Sedona. So folks, if you're interested, make sure you give it a try. And we are also like iterating on this function. And if you find any issues or bugs, let us know. We are happy to fix that. And there's another new function, although uh, it is uh, uh, it is pretty new. I still would recommend everybody in the call to give it a try. Is the
Hmm.
GeoStats. So that is the statistic toolbox we recently introduced into Apache Sedona. So that actually allows people to run spatial statistic analysis, for example, DB scan and
Right.
outlier detection as well as hotspot analysis. So those are the three initial functions we introduced, and you will be able to do that through pure SQL. But that is also another important thing. Yeah, so those are a couple cool things we have been having in open source Sedona, right? Uh, David, I know
Yeah.
you have some slides, and you
Yeah.
want to talk about the use cases you have in Comcast. So why not you share your screen?
Definitely. I do see, a couple questions. The first function, I think you're talking about was STD within. So it's like a distance within, it's a distance within join. So imagine, and you can correct me if I'm wrong, but you know, you create a buffer around a point or some type of geometry, and then the STD within will kind of return true or false if it's within that buffer.
Yeah, exactly. I just typed in the name in the chat, but let me find this in Sedona uh, website and share the link with you guys. Oh, yeah, I just pasted the link in the chat and you guys can take a look.
Yeah, I agree. That all very powerful. I use STD within all the time. I may do it using buffer and then ST intersects, but that's a much more simpler way of doing it. So I just uh, good to know. All right, well, I'll go ahead and set up my slides. All right, can everybody see them?
Yes.
Okay, wonderful. Yeah, so I just wanted to talk about the geospatial analytics at scale, specifically for telecommunications. So I'm going to dive into key geospatial analytics for telecoms, some of them relevant open source data sets so that anybody on the call can go explore these use cases themselves. And then, what is the infrastructure needed to do it at scale? And how does our team internally do it? So, while this is not an all-encompassing list of the geospatial use cases within the telecom sector, I've identified these use cases because I think they have a really large impact, and they're some of the most common that we have to tackle. So, understanding the customer experience for any company is essential, and this is especially true in mobile. And a significant impact for mobile customers and their connection strength are signal obstructions. And the most common signal obstruction is just being inside of a building, so being indoors. We've probably all experienced driving into a parking garage, and as we're driving in, as we get further inside of the parking garage, our connection might drop or it might buffer a little bit, or there might be some type of latency. So even like if you're just on a radio listening, that might happen too, right? Similarly,
David, do you
yeah.
mind actually enter the present mode so that
Oh,
way people can see your slides?
certainly. Presentation. Slideshow. Use presenter view.
No, just from beginning, click the button on the left, upper left, from beginning.
Yep.
Yes.
Oh. Are we in the right slide again?
Yeah, but I don't think it is presenting the slide. Do you have like multiple monitors? Probably want to share the correct monitor
Oh,
for.
I see what's happening. Yeah. Sorry. Screen two. Okay. All right. So you see it, and then the current slide. Is that better?
Great. Yes, great.
Okay. Sorry about that. Thank you. All right. So I was talking about indoor being a very common signal obstruction that we have to deal with. So besides just being inside the building, what can happen is a transition scenario. So let's say there's a coffee shop that you go to quite often, and so your device remembers the Wi-Fi connection information. And so as you're walking from your car into the building, there might be a transition period where the Wi-Fi is just strong enough to connect to your phone, and the cellular connection is getting weaker as you're going through. And there's that disconnect if you're watching something that's like a live stream or anything that requires no latency. So that's another common failure point. And similarly to that use case, when you're in transit, that same type of behavior can happen. So imagine you're in a subway and you're traveling, you're on cellular connection, and then you stop at a particular station. The station may or may not have a Wi-Fi connection that you're used to. Your phone's going to try to connect to the Wi-Fi because it's prioritizing not using your data. But then the train leaves the station, then you disconnect again. And probably the customer just wanted to stay on cellular so they don't ever have that disconnect. So that's another common failure point that any telecom company is trying to minimize those negative experiences and develop different solutions to address them. Yeah. Beyond that, we have signal coverage. I think everybody's familiar, with your cell phones. You see how many bars of coverage do you have, and typically that's just calculated by how far away are you from the infrastructure, right? That's a quick. I mean, you may get an actual signal strength from the cell tower, but if you're doing an analytics exercise, how far are they from the tower? Are there any obstructions between the tower and yourself? That's a quick geospatial join to get that type of distance, and you get fairly accurate information. It's very indicative of what the user is actually experiencing. And then the final point I have here is distance to infrastructure, but from a network expansion perspective. So fiber and cable. Back from my time in network expansion. So if you're creating a business use case for how, if I decide to invest in this infrastructure, how many potential customers am I going to get? How many people can we serve? And so typically you're going to have some type of line string that follows your road, you're planning it, and then you create that buffer, and then you see how many businesses or homes, you can do something like overture building data set, are within that buffer. And so you get these really great business plans without actually having to send somebody to go survey those areas. So you save a ton on cost and on your planning. Similarly, there are reporting requirements to the FCC to say if any telecom company has serviceability at that particular address. And the first step in that process, I would imagine, is to do this geospatial join again. So depending on how many feet or meters, it's not an exact science, you are from a building, you get a really great first pass on what could be considered serviceable or not. So let's say anything within 200 feet of your infrastructure is serviceable. Now, this doesn't always work because one example I liked is if you're at a cliff like the Wile E. Coyote, you have a building on top of the cliff and you have a road down here. Let's say your distance join is kind of like on a Cartesian plane, so you're not accounting for the altitude. Then perhaps this building on top of the cliff is not really serviceable. Or probably more likely it's like a creek or some type of water barrier that's in between the two infrastructures. And so it's not truly serviceable because you can't build across that creek or you can't build across that river that's within that buffer. But like I said, it gets a really great first pass. And I'll stop there. Do you have any commentary? Or and if not, I can continue as well.
Oh yeah, I think that those use cases are really, really interesting. So one thing though, so like you mentioned, so when you calculate collisions distance for the coverage, right?
Mhm.
Or the distance between object to the infrastructure, right? So
Right.
uh if you want to take into account the altitude, so what are the suggested approach for that?
Yeah, certainly. If you're wanting to take into the altitude, um, you know, I want to say it's not too common that that's actually done in some respects, because a lot of the analytical exercise, either the volume is so large that um, you're really trying to just execute at a really like high level statistic. Um, there's certain things. So I'll take a step back. When you're actually planning for the infrastructure and seeing how the signals propagate, typically you have to purchase something called clutter data. So you actually understand where every single tree is located, every single building, and that's how you get the most accurate signal coverage. But a lot of the analytics that I'm doing, it's a little bit higher level than that. So like if somebody calls a care agent and they say, hey, I had terrible coverage in this location, that coverage may be defined by something else. And so it's not necessarily how higher that individual is. Certainly there's different coordinate reference systems that you can integrate with the altitude to get it, but
Mhm.
it's not very common. But that's a great question. Yeah.
Oh, yeah, I see there are lots of people uh in the room. Folks, if you have any questions, right, so feel free to ask in the chat. And there is a Q&A session in the Zoom interface, right? You can also always ask questions there, and we're happy to answer.
Yeah, definitely.
Oh, David, I think yeah, we can move on.
Yeah, so a lot of the open source data that we utilize for our analytics purposes, and then you can get access to one that's amazing is the U.S. Census information, which is this first one. You get a lot of good demographic information. You get income, how many people live there, what is the housing population, the area. So just so much information to dive into. It's overwhelming, but amazing. The next one, the overture building data set. So we go back to the signal obstructions. Is an end user inside of a building or are they not? this data set's fantastic. We have U.S. government transit. So if we go, where are the trains? Where are the bus routes? How are these potential users interacting with these shapes? And then, back to reporting requirements, we have the FCC broadband data set. And this data set, I always recommend this data set for people who are just getting into geospatial because it's quite large. There's lots of fields to work with, things like provider, technology, down and up, and such. When you're first getting into, Sedona or anything geospatial, it's much more interesting when you have a real data set to work with. And this one's very relevant for telecoms. Next, we have something I like to call crowdsourced analytics within our team. So basically information that's provided in aggregate across, it's not like a benchmark. So if you go to speedtest.net, Ookla is the company that owns that website, and they capture all your speed test results. And in this case, they're showing an aggregation by quad bin. And so this is great to see, what is the average download or upload speed for a consumer within a particular location. And then, if we want to know your distance to infrastructure, we have open cell ID that, people report on where they see cell phone or cell sites, cell towers, and the different types of transmitters that are on those towers. So,
David, I see there are a couple questions in the chat, which are related
certainly.
to the slides, to the cropping here, I think.
Certainly. Okay.
So there's one question in the chat regarding, would there be a specific function you would recommend to determine overshooting cells?
Overshooting cells, consider relative directness of numbers closer than current cell. So that's an interesting question. I guess maybe I don't understand it completely, but is that for optimizing where the cell phone is connecting to which cell site? If a cell site is trying to connect, that might be okay. Got it. Yeah, certainly. That's going to be more at the algorithmic level of from the manufacturers, the people that handle that, and not necessarily within the purview of my particular team to decide which cell connection do they want to camp on. But I would say ST distance to just get a sense of how far away you are. But the actual algorithm probably likely has to do with something called RSRP, receive signal, receive power, and it's going to choose whichever one it has the highest strength from. There's other parts to those algorithms. Are you going to prioritize infrastructure that you own versus other people own? But it's not something we typically get into too often. Thank you. I also see a couple other questions I'll answer quickly. To Matt, the infrastructure that I'm running on, right now, our team is based in Databricks, and we're running Apache Sedona with Databricks as our compute layer. But we also have pipelines that run on-prem. And so so it's a mix, right? It goes back to that vendor lock-in. Even though our scripts are running on Databricks, we could really run them anywhere. And that's a really big value add, I think, for open source in general. And then Paul, I guess, what is your favorite source of geodata, i.e. shapes for state, county, city contours to get good geometries? The government provide, as part of the U.S. Census data set, they provide tiger shape files that dive into all of those different types of shapes. And the only thing that I would watch out for in those shapes, that they're really fantastic. I use them all the time. They tend to be very accurate and have a really high level of precision. And I go back to maybe we don't need as precise information as the government provides for those shape files, either due to trying to get our analytics to run more quickly or for data visualization purposes. Because if you have super high precision accuracy, the render time for geospatial data can really suffer. And that last question is a great question. I'll probably tackle that one later. And Paul was asking, when it comes to the implementation of the lakehouse, do you build a set of tables with all the different types of geometries, and then talk about the journey and lessons to create the proper data model and architecture? I'll tackle that in the slide, and if that doesn't answer the question, then I will come back to it. Yeah, I love all the interaction for the participants. It makes the talk a lot more interesting. So thank you, everyone. All right, so let me dive back into the slides. Okay, so as a data analyst background, we're typically trying to solve a question or a problem that the business is having. And I like to call this the search for causation. So initially, we have this shape is boundaries for census block information. And so maybe that was the first step of our analysis. And then after that, we need more insights. So we want to see, okay, we have the demographic information within the census block, but are these individuals in transit or not? And maybe that's still not enough. Maybe we need to know if they're in a building. So we go back to the Overture data set. So we're laying on top even more layers of geospatial information. Still not quite enough. We want to get the government transit data. Are they on the trains? Are they on a bus route? And how far away are they from these cell towers that we get from OpenCell ID? And so I think once you add all these different layers on top of each other, you get that picture, and you're able to answer a lot more questions, or at least get a lot closer to the cause. Maybe you don't find causation. Causation is really hard to find, but you get really high correlation. You get confident in your analysis, and it's a lot more specific than compared to non-geospatial analytics. So, talking about doing this at scale, what's the infrastructure required? So before looking at scale, you got to, first determine what is your data warehouse stack, what is your compute stack. I list, not an exhaustive list. There's so many tools out there, but some things that we have within Comcast that we've dealt with. Typical scaling problems. If you have like a PostGIS server, relational database, maybe it's too powerful for your needs at one point, but not powerful enough to ingest a huge data set that you just got without doing it in increments. And the speed that you need is, you need to get this done yesterday type activities, right? And so what I recommend, and what our teams really found success with, is Apache Sedona and Spark ETL, which can integrate with many, many different providers, right? It goes back to that vendor lock-in or the lack thereof. It's really, our pipelines are much faster and much more robust. So I'm just going to go through a quick code example, back to this favorite location that I have. So ST transforms, this is a very common step within different types of ETLs. When you're getting data from the government, you might get a different coordinate reference system, or EPSG, that's specific to a geographic location because they're being very accurate, right? But perhaps your analysis, you just need latitude, longitude, that's commonly used. So like EPSG 4326, which you're going to have your lat long, or maybe you need something for display or meter accuracy, so you're going to swap that to 3857. So you can see here we're utilizing that to go from lat long to this coordinate grid system. So after that type of transform, I go back to that precision. Maybe you don't need something so precise, and so we're going to reduce that precision so that we only get to the accuracy that's really, really relevant to our analytics exercise. Sometimes precision is very important, sometimes it's not. And the next step, in this case, we're utilizing an ST buffer operation. So we have the cell sites within the slides, And maybe the first ring that's light blue is 5G. 5G is higher frequencies, can't travel as far, and so that's when you're in 5G coverage. And then the red buffer is showing you 4G LTE. So you're still going to have connectivity, but maybe you're not getting those really high speeds. So also, you have the network infrastructure. ST buffer is something I use all the time. It's a fantastic operation. And then, back to that workhorse that I was talking about, ST intersects. So you'll notice from the slide above, there's two other points that don't intersect within the red buffers. And so the ST intersects is only going to return true the points that are within our join condition. So we lose those points. And now we just have the points that are relevant for our exercise. So more often than not, a lot of the enhancements that we're doing to our internal data sets or third-party data sets are going to be point and polygon operations, or polygon are touching. So this is, like I said, most utilized. And then finally, the ST union aggregate, and this goes to that data modeling question some. So perhaps your analysis, you are only interested in the coverage area. You don't necessarily care about which cell sites are the ones covering that area. And so you just want one row as opposed to two rows. So it always depends on the analysis that your end goal is. But ST union aggregate, I find myself utilizing quite often to work with that data modeling exercise of creating the primary keys or not. One caveat, if you're not super familiar with the data set and how all the geometries intersect, there's the potential for creating a very large, like, super object. And so that can cause a lot of data skew within your Spark pipelines. So it's really important to know and be familiar with the data before using that particular aggregation function. All right. And so I really want to touch on benefits of us doing this at scale versus something like GeoPandas, and I'm slightly running out of time here, so I'm going to jump through this quickly. Real-time analytics. We had a pipeline in GeoPandas. We're ingesting every single census block information and then joining it against one of our data sets, and it was taking 5 hours, so most of the day. And when we transitioned to Apache Sedona, and this is a single node on Databricks that we use to exercise this. So without really any tuning, it was kind of abstracted from us. We started running this pipeline within 30 minutes. And so, from the point of the very beginning of the call, this provided new insights, and new insights typically generate more questions. And so you have this cycle of really great data-driven decision-making within the business process. And that's really key. I mean, that's what you want from an analytics team, really, right? Impact to the business. So data set variability. So, at scale is great if you have a really big data set. You can keep horizontally or vertically scaling your compute for whatever task is at hand, and you can handle those really large data sets. And you're only going to pay for the compute that you're utilizing. But sometimes you just need a really small, single node, 32 gigs of RAM compute for, small data sets. Somebody just sent you a shapefile or a GeoJSON file, and you don't need the massive infrastructure. Well, that's fantastic in these type of compute environments because you only need to allocate the compute for your particular exercise. So, in PostGIS and some of the other tools out there, I think that's what it's lacking, is that ability to go from very small to very big very quickly, right? I don't even think about it at this point, but if we had a giant PostgIS server, I'm sure it could tackle a lot of our big data use cases. But at some point, it's going to be too much for our processes, and so we're paying more than we really have to. And then finally, that compatibility, that vendor lock-in, it works across all the different cloud vendors on-prem. I can share these scripts with other teams, and they don't have to worry about not being within that cloud provider or that location. And so that provides a lot of flexibility across our workflows, and that's really helped, I think. And I think the other teams too appreciate it, because if they're familiar with Apache Sedona, um, they're just like off and running very quickly. And then some other, when we're talking about big data as well, especially within geospatial, spatial partitioning and spatial indexing are incredibly important for performance. I've talked a lot about point and polygon operations, but really I aggregate a lot of my information by H3 index, or quad bin. And so that aggregation allows the analytics to be performed even faster, and it's quite crazy. But I'll just touch on, a quick ETL might be, I read in a shapefile or some other file through GeoPandas. GeoPandas has a lot of compatibility, and it's a lot easier than GDAL. And then from there, it's a single line of code to go from a GeoPandas data frame to go to a Spark data frame. And then once I get into that Spark data frame, I have access to all of Sedona's tools, which enable me to do the data modeling, to get into spatial partitioning, spatial indexing, and perform these joins against these massive data sets very quickly for that iteration. And you'll notice I have this middle process called visual data optimization. Again, we're going to go back to that modeling, that question from Paul. Let's say I have 100 speed tests in a certain building. And then when I would go to display that in most mapping applications, if I have 100 rows and 100 polygons of that building, I'm going to try to render that building 100 times. But that's going to make a really slow map. And so the hope is you have a table for statistics data. More often than not, those 100 speed tests, you want to get like the average download speed or the average upload speed, and then a primary key. And that primary key goes back to the building polygon or whatever your geometry is. And then a join between those two can go to the visualization tool of choice. One of the open source ones is Kepler GL, and Sedona integrates with Kepler GL as well. And then from there, you get application specific tuning. So, if your zoom level, if you're looking at the entirety of the United States, you probably don't want to render building polygons that are in a particular city. You probably want to look at, state level information. But then as you dive down and zoom in closer, then you probably do want to see building level, renderings. And Jay, that's what I have for all my slides. Happy to answer any questions about it. Kind of breezing through since I know we only have a few minutes left. But
Yeah, great. Yeah,
great.
there. Thanks for the great presentation. There are a few questions in the chat as well, actually. One from Matt.
Yeah. So Overture, the question is, have you begun to integrate GERS into any of your Comcast specific data sets? Yeah. If so, any high level advice and thoughts? I will say I'm unfamiliar with the GERS acronym. Gia, do you happen to know what that is?
Yeah, so GERS is I would say it is a new feature Overture introduced into their dataset, I think a couple releases ago. So GERS is essentially a they're assigning a global ID to the features they have in their dataset. So basically that allows you to understand the change of the same object over time across different releases.
Okay, that's excellent. Matt, the quick answer, as you can tell, is I have not integrated GERS into any of the Comcast specific data sets, but that is something I definitely want to look into. Typically what we do every time Overture releases a new data set, we recreate some of what I would consider our base tables that have indexed or hashed the Overture information, and then we'll reperform all of our joins, as opposed to doing it by a diff statement. It sounds like GERS would be able to handle. And then Paul, how much data am I serving with this app, and roughly in terms of gigabytes? We're ingesting probably 50 gigabytes of information a day specific to our team. So that's within Comcast, that's one reason I actually love working with Comcast. There's very few companies that deal with the volume of data we deal with. And not my team in particular, but just in general, all the information that's going on the network and all the derivative analytics and the number of customers. But our pipelines are 50 gigs typically, and they run between 20 and 30 minutes with the compute that we've selected, right? We can always make the compute larger and those pipelines go faster, but to meet our SLAs, it's 20 to 25 minutes. And then I guess the follow-up question, Paul, we're storing most of our information in S3 buckets in Parquet format, or Delta format. We're in the Databricks environment, and so we can store in Delta as well, which is Parquet based. Overture into Databricks, so they provide a capability of reading the S3 buckets, and so it's just using the APIs that Overture provides to bring that data in. All right. So Ricardo, is it possible to read data straight to Apache Sedona and not use GeoPandas data frame? Reading in GeoPandas adds one step that uses memory, right? That's a great question. It is possible to not use GeoPandas, and for certain data sets, it would be impossible, right? Because the data size. To your point, if data comes in as GeoJSON or like a or a shapefile, it is possible to read it in using Apache Sedona, and I would recommend doing that.
Yeah, I'd like to add to that. So, Sedona offers several native readers that can read a bunch of different spatial formats that includes Parquet, GeoParquet, GeoJSON shapefile. Recently, we also added reader for GeoPackage, as well as in the upcoming release, we're also going to introduce a reader for OSM PBF, OpenStreetMap PBF. So that actually can load data from S3 directly at scale. So you don't have to go through the GeoPandas. But if there are some kind of less common data formats and you still want to read, so you're going to use GeoPandas to read that and convert that GeoPandas data frame to a Sedona data frame.
Exactly. Yeah, just to piggyback off what Jia said, GeoPandas has a wide range of compatibility, and so that makes it very helpful to use. But more often than not, like the data sets that I'm reading in, we're getting geometry information as WKT format, which is like a string format, rather than actually as a geometry type. And that's a common restriction on some ingest processes. For example, Redshift. Redshift, typically when you're reading in the data, it's limiting the objects in size. And so you have to split your geometries and then get them into string formats, and then you can ingest it into Redshift because they don't have a native JDBC connection that can handle the geometry types. Sorry, I realize I'm reading people's questions myself, but not for everybody. There was a question from Claire that said, do you use feature classes in your workflow? We have found that GeoPandas crashes with many gigabytes data sets. That was what that was related to. Is the app-specific query pointed to the data store done in Sedona also, or is it a different system? I'm not sure I understand that question entirely, but I want to say when the data is stored in the S3 bucket or like Parquet format, then you're just reading it into Spark, and then Spark has access to the functions that Sedona implements, as part of the, when you're creating the compute environment, installing all the different libraries. And so that, it can be stored on, disk or in RAM. I hope that answers your question, Paul. And Matt is asking, what do your outputs look like for the geospatial data? Is it mostly maps or non-spatial outputs? It's incredible how many times I've seen a business person have an aha moment when they see the maps that we're generating. They see information in Excel, you have all these different splits. But once they see it on the map, they're like, oh, this is the greatest thing ever since sliced bread. So we typically create maps using Sedona Kepler, or if need be, Tableau actually does handle geospatial data, not super well because it crashes on the volume, but it is possible. And then you have other tools like Carto, which is a specific mapping tool for big data that's geospatially related. I know we're at time, Jay. I have a few more minutes, but
Cool. Yeah, so I'll say one last question from me. It is a more
yeah.
general question. So what would you recommend to new users when they start to play with big geospatial data using scalable spatial data processing tools? Not necessarily Sedona as well, right?
Mhm. Yeah, that's a great question. I love containerization. I think it helps with a lot of the setup. I think sometimes people's barrier to entry is getting the infrastructure there. But if you're technical enough to go to a Docker repository, there are containers already set up with Apache Sedona that are made to run locally. A single node cluster to get started. So I recommend going to that website, downloading that image, running that container, and then working out of a Jupyter notebook. I think Jupyter Notebook is a great way to interface with Spark and do inline analytics for your processes. Start with a small shape file, limit to a particular area, and get off to the races from there.
Thank you, David. So I also heard that you're looking for talents who have skills in Sedona or scalable data processing, right?
That's correct. Yes, we're probably going to onboard some new engineers in the near future. And if you're in the Philadelphia area, we're looking for data engineers with a lot of Spark experience. And for me, whenever I see resumes, if they have Apache Sedona or Geospatial on it, that's a huge value add because we're always willing to train and upskill people. But if somebody already has that talent, and that's a way to stand out for sure.
Cool. Yeah. So if you have any job description or links you want to share with the audience, we are happy to share that with the audience through emails or the call.
Certainly. Yeah, the job is not posted yet. It's probably going to be posted in sometime in the near future. No timeline given for that, but happy to share it. And if anybody who's on this call, they're interested in Apache Sedona, or they're already very familiar, and they just want to hear Comcast's journey, I would highly recommend applying.
Cool. Thank you, David. And thanks everybody for attending the live stream today.
Appreciate
All
everybody.
right.
Thank you for having me.
Thank you, guys. Bye.